Just some straight facts about alkanes, saturated alkanes. Saturated alkanes, they contain all single bonds. There are no double pi bonds in there. All single or sigma bonds. There are no double, no pi bonds, no triple bonds in an alkane right there. Now, alkanes can be straight chain, like this one here, like this pentane. It could be a straight chain. It can also be branched. This is an example of a branched alkane that also contains 5 carbons. 1, 2, 3, 4, 5 carbons here. It can also be cyclical. And here is cyclopentane, a 5-carbon ring. We don't draw carbons and we don't draw hydrogens because we're lazy. You are meant to understand that the carbons are at the corners and the hydrogens aren't drawn. It's up to the reader to fill it in right there. These contain single bonds, all sigma bonds, no pi bonds or double bonds in here. They contain carbon and hydrogen only. There's no oxygen, nitrogen, or fluorine or anything else going on in here. These things have a low water solubility. They do not dissolve in water very well. Water is a polar, inorganic substance. These are non-polar, and this straight one too. These are non-polar organic substances. They do not dissolve well in water. These are also less dense than water, meaning that they will either float on top of the water surface or maybe even just below. During oil spills, when the raw crude petroleum or refined petroleum products are spilled into the ocean, it either flows on top, or because the oceans are saline, sometimes, and the densities are a little different right there, sometimes it'll float like maybe 10, 15 meters under the surface of the water right there. But they're mostly less dense and will float or be on the top layer when in water right there. There is a correlation between the number of carbons and the melting and boiling point. The more carbons, the higher the melting point. So this is pentane. And this is ethane right here. If I had a solid block of pentane and a solid block of ethane, and I heated them at the same time, I would expect this to melt and go to liquid phase at a much lower temperature. It takes more energy to move more carbons. These are 5 carbons here. There's also a correlation with boiling point. The more carbons, the higher the boiling point. So again, if these were both liquid and I was heating them on the stove at the same time at the same rate, this would go to gas phase at a lower boiling point. This would take a higher temperature, i.e. more energy, to be able to float off into gas phase. I only have one of these pentane molecules here, but if you can imagine a neighboring pentane molecule, they can twist longer hydrocarbons, and alkanes can kind of twist into one another like strands of spaghetti. And that's one of the mechanical reasons that why it takes more energy, or they have a higher, the more carbons, you have a higher melting point and a higher boiling point. I hope this helps. Thank you.